So you either wind up shading everything above the line or everything below the line. And then for this, they do the same thing. They make it an equals, and then you'll find out in pre-cal that that's the equation of a circle of radius 3. And then you pick a test point either in the circle or outside the circle. And you wind up testing, and you wind up saying it's everything outside or everything inside. The point is, set it equal to 0, test points is a common thing that just, with inequalities, you just do, all right? All right, let's talk about the test. I would suggest that after you take the test on Thursday, you go do this homework, all right? I wouldn't expect for you to necessarily do it tonight, but the homework for this section, oops, wrong class. The homework for this section, 5.5, it says to do number 5, do number 7, and then 19 through 41. Just try the 19 through 41, right? Just try that. All right, test, exam 2. How much time did I leave? A lot of time. Exam 2. Can't believe we're only taking exam 2 right now. Seems like it should be exam 4. So exam 2, you're allowed to have a reference sheet just like you had on exam 1, right? So that's a standard sheet of paper, right? 8.5 by 11 sheet of paper, front and back. You can have formulas, steps, procedures, which you probably want for this test, right? You want to remember all the steps to graph a polynomial. You want to remember that table, right? For rational functions, you want to remember the 3 cases for horizontal asymptotes. Like everything. This is the test to have a reference sheet on, right? So make that sheet. Make sure you don't work out any problems. Nothing worked out, okay? Just steps and procedures. Yes?
I couldn't find the review on Canvas. Where is it posted?
I emailed it, right?
No, it's on Canvas.
Yeah,
It's like in the inbox.
What?
It was just in the inbox.
It was in the inbox?
Yeah.
I emailed it through Canvas email, so check your inbox.
I
also got a-
box doesn't work right now.
It does? Okay,
I
well,
got a PDF through the school email too.
you got it through the school email?
Yeah, I don't know why it's in there, but I got a PDF for it in there.
Interesting. But if you're not able to get to it, see me after class and I can find a way to try and send it to you. Okay, so reference sheet, any questions on the reference sheet? No? Okay, now in terms of the review itself that I did send out, I gave you this review to give you some idea, right, of what to expect, but I recommend that you go not only do this review, okay, look at the quizzes I've given you, all right? The quizzes I've given you as well, because this may not be where I pull everything from. Like I remember I gave you like that quiz where I drew a graph and I had you come up with the function. That's not on the review, but that to me would be a fair question. I mean, I quizzed you on that, right? So to ask that on a test, I think is fair. So go back and look at your quizzes as well. I handed all the quizzes back last time, I believe, right? Yeah, so I did not bring them. I don't. I can look at them. Yes?
Do you still want my hard copy for my second picture?
You sent it to me already electronic. Turn it in next time. That way you have it and you can look at it. Okay, so just a quick synopsis here of what you're going to be asked to do, potentially. I give you a function, and then you need to know what the transformations are and then sketching it, stating the domain, stating the range. So there, like this problem, you have to know what the square root function looks like, right? And then what happens? Do you want to talk about this or no?
Flips upside down.
So you've got a flipping, right? The -3 out here is a reflection over the x-axis. The 3, what does the 3 do? Stretches it out vertically. What does the +4 underneath the root do? Left 4. And then the -2? Down 2.
Do you want us to put down 2 units or just put down 2?
You can just say down 2. So when I say list the transformations, what I want you to say is like reflected over the x-axis, stretched vertically by 3, shifted to the left 4, shifted down 2.
Do you mind if we just put arrows?
Arrows are fine.
Okay.
Like up arrow 2 or down arrow 2, left arrow 4, that's fine.
Okay.
So then you sketch it, then you state the domain. Let's just do it. This one's not that hard to do. So this is the first problem. So I know what a square root function looks like. That's what the square root function looks like. And so what I imagine doing to this is I can reflect this over the x-axis. Let's reflect it first. That's the reflection. Okay, so that's negative root x. This is root x. That's negative root x. Then I'm going to stretch it by 3. What that does is it stretches it like this. Just makes it vertically get stretched. That's negative 3 root x. And then I'm going to move the whole thing to the left by 4. 1, 2, 3, 4. So now it's this. Okay, so this is negative 3 root x plus 4. And then that whole thing down 2. So if I go down 2, this will be my final picture. So it went down 1, 2, right there, and now it goes like that. That's it. That's all I want. What's the domain? Where does this graph exist in terms of your x values? From here, forever. So that's domain is what? 4 to infinity. Negative 4, sorry. Negative 4 to infinity, right? What's the range? So that's the y values. Is the graph down there?
Yes.
All the way down there, right? It goes, and then where does it come up to? It actually stops where? Negative 2. So the range is negative infinity to negative 2, including negative 2. So you should be able to draw the transformations, and from that you should be able to determine the domain and range. I haven't made the test yet, but, you know, I'll make it tonight. What?
10?
I don't know. I don't know. Okay, next problem, sketch a quadratic function. Oh, no, sorry. No, that's not what convert this. Convert this into standard form. Do you all know how to do that?
Yes.
You don't? Yeah, so what you do here, there's 2 ways to do it. One of them is completing the square, which I showed y'all. The other way is to cheat a little bit. Let me do it by completing the square, because that's the way I did it in class, all right? So I've got to turn it into that form a times x minus h squared plus k. I've got to make it look like that. So to do that, I complete the square. First step to completing the square is making sure that that's a 1. It's not. So I pull a 3 out. I'm left with x squared minus 2x. Do you remember this? This is weird, right? Because you pull a 3 from here, a 3 from here, but then you also pull a 3 from here. That becomes what? Minus 7 over 3. Does this not look familiar to you all? I pulled a 3 from this, yes. Right? Pulling a 3 out of this just leaves me with x squared. Pulling a 3 from this leaves me with negative 2. Right? So if I distribute this through, I get this here, gives me that. This to here gives me that, right? And then this is weird because there's not really a 3 here, right? But I can kind of be clever and just divide 7 by 3. And do y'all see if I multiply this back through, do y'all see I get 7 minus 7? Okay. So now, we've got a 1 here. That's what you need to complete the square. Do y'all remember the next step? Did we complete the square? Does this seem?
Not very long.
It was very short, yeah. Okay. I did show y'all. I said y'all are acting kind of like you've never seen it.
Like a thing.
Yeah, it was just a part of one class. Okay. So what we do is we take the number in front of this, x, negative 2, and we divide it by 2, always. And that gives us negative 1.
So you always divide divide the second.
You always divide the coefficient of the x term by 2, and that gives you this number. Then you take that number and you square it, which gives you 1. This is that part I was telling y'all in class about. This is, remember the hidden 0? We're going to see a hidden 0 here. Y'all are really acting like I didn't show y'all this. There's a plus 0 here. Minus 7/3. I'm going to take this second number, I'm going to add it and subtract it right there where that red 0 is. I'm going to add 1, subtract 1. And then I have minus 7/3 here.
What's the skull?
Completing the square. Yep. Well, completing the square the way I show it. I told y'all in class that it's normally shown where you do something to both sides of an equation, but in Cal 2 you'll get stuck in the middle of a problem because you don't have an equation. So you need to be able to have this hidden 0 idea. So that's what I show y'all in here. Okay, now if you do this method, right, you do this correctly, then you are guaranteed that these 3 terms right here are going to factor to be something squared. And it's going to be this number next to x minus 1, like this. So I take x and then I subtract 1. So if I FOIL this out, right, if I do x minus 1 times x minus 1, I FOIL it out, I will get these 3, guaranteed. That's what completing the square is about. It's about getting this to become something squared. But that still leaves me with these 2, right? Right here. Minus 1, minus 7/3. Common denominator here. Put these together. So this is the same as 3 over 3?
Minus 3/3.
So this becomes 3 parentheses. Then I have the x minus 1 squared. Then minus what?
Minus 3/3.
3/3. So it'll be minus 3/3, but then minus 7/3, which is minus 10/3. One more step. Distribute the 3, which means push it right in front of this parenthesis and distribute the 3 to here. 3 times x minus 1 squared minus what? 10. And this looks like this. Right?
That 0 is gross.
This is one of the most important tricks in math. I mean, it's such, I know it's crazy like to do it, but it's like when humans started figuring out that we could do things like this, it really pushed what we could do. The hidden 0 is a big idea. I mean, you've been doing something similar to it your whole life. Anytime you've gotten a common denominator, like adding a fraction, like if we add these fractions, what are you doing? You have to get a common denominator, right? So you multiply top and bottom by 3 here and 2 here. What you're really doing is multiplying by 1, right? You're not freaking out about that, are you? I mean, you can multiply anything by 1 and it's still itself, right? Well, I can add nothing to anything and it's still itself, right? So it's the same sort of concept, but with addition instead of multiplication. Multiply by 1, it doesn't change anything. Add 0 doesn't change anything. It's just we're going to be very clever about that 0. Okay. Now, y'all look like y'all were about to freak the hell out, right, when I did that. So I'm going to do it a different way, just to give you this is like a, what do they call it, a fail-safe for the test. I'm just going to show this to you real quick, all right? Can you tell me, with this formula right here, right, this is called the vertex formula. The other form is this one, which is the one we were given, right? This is this. We're trying to get to that. Can you tell me at least what A is? A is 3, okay? A is 3 for both of these. Now, all you need is H and K now, right? That's all you need is H and K? Well, I gave you a formula for H. What's H? Negative B over 2A. Look in your notes. What's negative B for us? So B is negative 6, right? What's negative B? Negative 6? over 2 times A. What's A? 3. So this is 6 over 6 is 1, right? So H is 1. Okay? And then how do you find K? You take that answer 1 and you plug it into the function. So take that answer and plug it in right here. 3 times 1 squared minus 6 times 1 minus 7. And what do you get when you do all this? Should get, what do we get? Hold on. Something ain't right. Minus 1 plus K. You get negative 10? What am I? Oh, this is 3. Okay. For some reason, I was thinking this was 6. Because I did that and multiplied like an idiot. Okay, so this is negative 10. Okay, so do y'all see right here, if I replace that with 3, replace that H with 1, and replace that with negative 10, do you see we have the answer? Right? Yes? Okay, that's your emergency exit, okay? That's your emergency exit for that problem. But if I ever see you in Cal 2 and you can't complete the square, I'm going to kick you out of the class. I won't really kick you out of the class. I'm just saying you need to know how to complete the square. So, you know, given that the test is in 2 days, that's a way that you can get this problem without having to complete the square or to check your answer, all right? Yeah? Yes?
Can I just make sure that the domain was all real numbers?
Domain, yeah, all quadratic functions have a domain of all real numbers.
Okay.
And then the range, how would you figure out the range? Well, you know the vertex, don't you?
Yep.
The vertex was what, 1, negative 10?
So,
Down here, 1, negative 10. And this parabola opens which way? Up. So your range is from negative 10 to infinity. Okay, let's, yes.
On the reference sheet, can we work out the variables? Like, can we put a bunch of variables and just spread out the equation to make it?
If
look
you,
like that, or
yeah,
not?
you could use some weird hieroglyphic shit that only you understand, you know, that only you understand, like that's fine with me. Like make up your own language, I'm okay with that. All right, next problem, number 3. I want you to sketch a quadratic function. Okay, I don't have time to go through it, but just as a recap, to sketch a quadratic function, what are the steps? First, does it open up or down, right? Up or down. You look at A, does it open up or down? Second step, you find the vertex. How do you find the vertex? HK, that formula. Third step, you do a quick little sketch to see how many x-intercepts you have. Y'all should have this all written down, yes? And then after you find your x-intercepts, yeah, you're going to find the x-intercepts, right? Set it equal to 0, solve. How do you solve that quadratic, setting quadratic equal to 0? You can either factor if it factors, but always you can always use a quadratic formula, right? Okay, be prepared to use a quadratic formula for a problem like that. Be prepared. Because I'm not going to force you to use quadratic formula much on this test, but I will have you do it at least once. So I would think like number 3, that type of problem would be a good place for me to force it to happen. Let's see. Is that okay? Sketch it, boom, move on. Number 4, can you sketch that? What do you have to figure out first?
bounce cross.
Well, you can tell me bounce cross right now, right? At 2 it what? At 2 it crosses, at negative 3 it bounces, at 7 it bounces, right? So you know your bounce cross. What you don't know is what? End behavior. How can you determine the end behavior? The first one, right? Let me do something here. The first one, it'll be easier for me to kind of point out it here. Yeah, you're going to kind of add the exponents to see what the power is. But I actually gave you all a technique for this, so I want to make sure that you understand the technique. What was the question you were going to ask me?
Oh, it was basically the number.
Which number? The first one? Okay, so we've covered? Okay, good. I want to make sure I get to that because you asked me at the beginning. Okay, so I'm talking about this problem here, right? So this one right here, I know if I set these equal to 0, I know that I get 2, -3, and 7. I know I'm going to bounce here, and cross because of these powers, right? But I still need to figure out the end behavior. So what I do is on the first one, what I do is I take the x term. This is a 1x, right? And I imagine what would happen if I cube it. And then times, then I take the 1x here, and I raise it to the 4th. Oh, 1x raised to the 4th. And then I take, again, the 1x here, and I square it. So the good thing is that there's a bunch of 1s in there, right? So the 1s don't really matter. But let's just say on the test that I gave you this was -2. Right? What if this was a -2 right here? Then it would be -2 cubed would be -8, wouldn't it? So you have to pay attention to the numbers as well as the powers. So this right here would just give me x cubed. This right here would give me x to the 4th. And this right here would give me x squared. So what's the total power here? X to the, what do? Add or multiply these? Add 7, 9. This is like an x to the 9th with a 1 in front. Why 1? Because I had 1 times 1 times 1. So what does that do? Down on the left, up on the right. Does this. Okay? I may as well draw it. I've come this far. Where are my x-intercepts? -3, 2 and 7. I know I go down the left, up on the right, and I am bouncing at -3, bounce. I am crossing at 2, and bouncing at 7. There it is. I'm done. So number 4, the easy part of number 4 is you can tell me the x-intercepts and the bounce and cross just by looking at it. The harder part of number 4 is that you have to think a little bit about the end behavior. You have to kind of analyze what's going on. Number 5, on the other hand, is the reverse. On number 5, you can tell me the end behavior right away because you know the degree and you know the leading coefficient. So this one would also do this, right? But you don't know the x-intercepts and you don't know the bounce cross, do you? Which means you have to factor this. So what are the steps for doing a polynomial? There's a set of steps. The first step is end behavior, right? Second step is x-intercepts with multiplicity. Those are the steps. And then you draw it. So I'm not going to go through this, but if I were to set this equal to 0, the very first thing I would do, the very first thing you would do is what? Pull out the x squared. And don't forget about that x squared. I'll see students that'll pull an x squared out, right? And then they'll start doing the rest of it. They'll do synthetic. They'll do it all perfect. And then they set all their little things equal to 0, and they get their bounce cross, and then they forgot that there was an x squared. Always just bring everything back together, and that way you have your final version. Number 6 is the same thing, right? Number 6 is exactly the same. I just gave you 2 examples to work with for the review. And then number 7 and number 8. Now we got rational functions, right? So there's all the steps, right? Set that to 0, right? Well, wait, hold on. We had a set of steps. What was the first step? Completely factor, right? Completely factor the top and bottom. Second step. Check for holes. Check for holes. Then, after you've checked for holes, find the x-intercepts by setting the
Greater than 0.
top equal to 0. Whatever's left. Remember, if you have holes, cancel those and they're gone. All right? So then you set, after you've done that, you set your top equal to 0. That'll be wherever you have x-intercepts. Then you move on. You find your vertical asymptotes. To do that, you set the denominator equal to 0. And then after that, you look for horizontal asymptotes. And that's where you have to compare the degree of the numerator and denominator. If they are the same, like they are here, if they are the same, oh wait, you know what? There's a hole in this one, isn't there? There's a hole. Do y'all see there's a hole here? If I can pull an x out of this, right? And I can pull an x out of this, and there's a hole at 0. But we're already past that step. These have the same degree, right?
And it doesn't have a horizontal axis.
It does.
Wait,
If these are the same degree, right? Then you look at the number in front of here and you divide it by the number in front of here.
oh, it's with the when the exponent's greater on the top, then it doesn't.
No, it's when the exponent is greater on the bottom. Oh wait, that it doesn't? Yeah, when it's greater on top.
When it's greater on the top and
Then the bottom, it doesn't have
it
one.
doesn't have one.
If it's greater on the bottom and top, then it's the x-axis. Or the y equals 0, however you want to say it. So, I mean, I can't obviously do these problems. These problems took us like 20 minutes to do, right? So, get your horizontal asymptote. Then you plot all your information. You draw it, right? Right? And then you need what to finish test points? How many test points will you have? Always going to be one more than the total number of x-intercepts and vertical asymptotes combined. So if you have 2 x-intercepts and 2 verticals, you're going to have 5 test points. If you have 1 x-intercept and 2 verticals, you're going to have 4 test points, right? One more than the total number of x-intercepts and verticals. All right, so there they are. Try those out. And that's it. That's it. That's all the test is over. No, there was something else, right? Your quizzes, right? Look at your quizzes. Oh, why am I opening that? What the hell? I'm in the wrong class. Oops.
Did you say that piecewise functions?
Yeah, that's what I'm bringing up here. What? The review is what I wanted. There it is. So this right here, we did not cover on our first test, number 16. And this is where I give you a function defined to be like 2 or 3 different functions. And so you have to sketch it. You have to sketch it. So like for this, you have to know what those 3 functions look like. And so like on a graph, to the left of -1, when x is less than or equal to -1, so here's -1, you're supposed to look like the absolute value function. The absolute value function looks like this. You have to know that. But we're only going to go from, with x less than -1, so we only want to go from here, less than or equal, out like this, and then we erase this part. So that's the first piece. The second piece is between -1 and 1, it looks like x squared. X squared looks like a parabola, looks like this. Like that, and it's closed here, and it's open here. I'm very, very quickly going through this. Then it has to look like the square root of x from 1 to 4. So square root of x would go like this, like that, and we want to stop it. 4, so here, it's this, but we erase here because we only want to go from 1. That's what the graph of that piecewise function looks like. And then you have to answer all the questions. So sketch it, done. Find the domain. Well, the domain from this, it goes this way forever because there's an arrow here because it didn't have a restriction up here. It didn't have a restriction. So from -infinity all the way to 4, including 4. Range would be from where? Nothing down here, right? So from 0 to, this goes forever. Infinity. Any x-intercepts? 0. Where's the function increasing? Ooh, that's a tricky one. Where is it increasing? From 0 to the right, you're always going up. Where is it decreasing? Here, right? -infinity to 0. Local maximums. Do you have any local maximums? Maximums, local. You could say that this right here is a local max. You could say that that endpoint is. I had a debate with some other faculty members here about this question, about local extreme values. Some textbooks, and I told you all this the day I covered it, some textbooks will not consider an endpoint to be a local max or a local min, and other textbooks do. And so we were in a pretty heated debate about it. It's inconclusive. It depends on how you define it.
It's gonna depend on the teacher.
It's going to depend on, it really will depend on the teacher. But the thing is, we still are not going to lose the spirit of what it is, right? Like this is the highest point locally. Like in this little area, that's the highest point. Let's see, local max, you could, you could say that. Local min would be this bottom one, bottom point right there. And then, what is the absolute max? Does this function have a highest point? No, because this arrow goes up forever. Does it have an absolute lowest point? Yeah, 0. Okay, it's been a long time since we did that, right? But that again is fair game because it wasn't on exam 1, so it can be on exam 2. All right, everyone, study. I'll see you on Thursday. Get some rest. Yeah, have a good one. Let me jump on my camera real quick and get out of there.